I welcome you all for today's session, Data RAM Allocations in C. So here in the previous session we discussed about the programming RAM allocation in C. Now we are going to discuss about the data RAM allocation in C, which refers to the process of allocating memory space in the random access memory, which is named as RAM, of a computer system to store data during program execution. In C, there are primarily two types of RAM allocation named as static allocation and dynamic allocation. So we should know about what is static allocation and what is dynamic allocation. First, let us discuss about static allocation. So the static allocation is done at compile time, given compile time. The memory of variables is allocated when the program starts and persists throughout its execution. So the variables declared outside of functions like global variables or with the static keyword within functions are statically allocated. Example, integer global variable slash statically allocated global variable. Again, static integer static variable, then statically allocated static variables. So next one is dynamic allocation. In dynamic allocation, this allows memory to be allocated during runtime. So the memory is allocated from the heap segment of RAM using functions like MALLOC bracket, then CALLOC or REALLOC. So the dynamic allocation provides flexibility in memory usage but requires explicit memory management by the programmer. So for example, we can write integer start dynamic variable. So the dynamic variable here is integer. It may be malloc and size of integer or dynamic allocation. So this is how we define the dynamic allocation in three parts like MALLOC, CALLOC and REALLOC. That is mail allocation, call allocation and real allocation. Okay, read allocation, call, read allocation. These are the two types of allocations. Okay, so here let us discuss about the stack allocation. Stack allocation is used for local variables within functions. So the stack allocated variables is automatically managed by the compiler. So the variables are allocated and deallocated in a last in first out. So in array we used to say it as first in first out. In stack, last in first out. So stack allocation is fast but limited in size and scope. Example, void some function, then you have to open the bracket, then integer stack variable, then stack allocated variable, then we have to close the program, and this is the syntax of a stack allocation. And next one is stack. So far we discussed about stack, and now we are going to discuss about heap allocation versus stack allocation. Heap allocation is suitable for larger or dynamically sized data structures, whereas stack allocation is preferable for smaller, shorter lived variables. Heap allocation requires manual memory management, allocation and deallocation by the programmer, while stack allocation is managed automatically by the compiler. So improper use of a heap allocation can lead to memory leaks or fragmentation, while stack allocation is generally safer and more efficient for managing local variables. So, understanding data RAM allocation in C is crucial for efficient memory management and optimizing the performance of C programs. So, the programmers must choose the appropriate allocation method based on the specific requirements of their applications. So, this is all about the data RAM allocation in C. Thank you.